I'll be talking about a project we've been working on for a couple years. Our 3GSE paper is titled a Case Study in Helping Students Covertly Eat Their Classmates. And this project is a cybersecurity educational game. And our project's motto is, if you're not cheating, you're not trying. So I'm Mike Jacobi. I graduated with a master's degree 2 years ago. And Roya and Ensafi helped with this project, and our advisor, Dr. Jed Crandall. So before I begin, the game that we emulated was actually a kind of a social dinner party game called Werewolves of Miller Hollow. And that's a game that consists of two teams. There's werewolves and there's townspeople. And it's the goal of either team to eliminate the other. So the werewolves are, they'll participate at night, and they quietly discuss whom to feed on and eliminate. And then in the morning, during the day, the moderator will say that one of the townspeople is eliminated, and then the moderator prompts the town to discuss and then vote on someone to hang. And so this happens. There's a series of rounds, night and day. This is facilitated by an omnipotent player, the moderator, and after one of these teams is gone, the game is over. There's also a number of special characters. One of these is the witch. The witch has two potions, a health potion and a poison. The health potion will revive the player that the wolves eliminated that night, and that can be used once per game. And then the witch also has a poison, and if the witch thinks that they know a werewolf, the witch can use the poison on that player and eliminate them from the game. And so there's also a fortune teller, which we have expressly eliminated in favor of encouraging our players to use side channels. And so the fortune teller is this character who, once per round, can prompt the moderator to learn the true identity of any player in the game. And so we've removed the fortune teller, and in place of that, players are doing that on their own. So in our version here, it's a client-server architecture in which the moderator is automated and facilitates these rounds of night and day and kind of the state of the game. And then we have players that connect to the server via clients. And so the moderator is responsible for things like waiting for connections and assigning roles. That can be done either manually or automatically, depending on the state and the sophistication of the players. And then things like which day is it, who is allowed to discuss right now, who's still alive. And this is all configurable with just some initialization scripts. And that lets you do things like I said, control the manual or automatic generation of teams, enable or disable various exploits, which I'll go over in a minute, and really kind of tune the server to the ability of the players. And so the players, they're given a client to connect, and that client's very noisy, not very sophisticated, and it's their goal to improve the client that they're given by writing tools, essentially. So to go into a little bit more detail here, the game takes place on a single server, and players are SSHing into that server and using these clients to connect. And they communicate between each other by using Unix named pipes, which are essentially first in, first out data structures. And the server is responsible for controlling who can chat at any given moment through a series of these pipes, and also handling things like voting, which is all based on a series of pipes. The goals here were we wanted to create an environment where players were kind of teaching themselves, and so we do that by kind of showing them the types of things that are possible with like what is a named pipe, and how can they interact with it, and what does that mean in terms of the noise that it creates on the system by interacting with it. And so along with those kinds of ideas, students are encouraged to learn a lot of command line techniques and then some scripting, because this stuff needs to be automated to start deducing the roles of other players. We've strongly encouraged the systematic analysis of the system, and that's really the only way you're gonna decipher any usable information, because things are happening too quickly to do it manually. And then also, this is distinct from a lot of the CTF talks we've had today. It's player versus player, and there is no scoring. It's kind of more of just a game with an actual end, with a goal in mind. And that means there's also losers in this game. But we tell our players that they need to find their information leaks and exploit them, and exploiting bugs in the server we also encourage. We had a discussion about open sourcing of the servers. All of this code is online, and we start on day one by just giving the server to our players, which was fun. So the origins of this game kind of turned it into what it is. It started in a 500 level CS class. We had 45 students. We broke them into teams of 3. And after about a week of introduction of explaining what the game is and how it works, we went into this weekly cycle where students would play on Monday, learn some of the theoretical ideas behind side channels and information flow on Wednesdays, and then on Fridays they would be encouraged to put what they learned to use. And by that I mean to code up some of the ideas, some of the theoretical ideas that were presented in lecture form. And meanwhile, while this was going on, we, on the development side, were patching the exploits that were inevitably found on the server, and turning these bugs into configurable options so that we have this tunable server. And so because we developed it alongside with playing it in this kind of informal environment, what we have now is about 10 or 15 bugs that we can turn on and off. And we've put this game in front of different classes of students and kind of allowed them to discover vulnerabilities on their own, go through the process of discovery. So this is, I just wanted to talk about a couple of the things that are possible in this game and the types of attacks that that we expect to see. So every night there's a round of werewolves voting and then of discussing and then voting on whom to eliminate from the game. And so when that happens, what it looks like is the moderator will send some incriminating string from the server to each of the werewolf clients, and that creates noise in the system that can be detected. So if you look here at this screenshot, can you guys see my cursor there? What you see there is an incriminating string being piped to one of the named pipes. And so one possible attack is to look at the modification time of that pipe, and you'll see here that it changes ever so briefly. And so I think you can see how if you were to script that, you'd be able to see when certain pipes were being communicated with. You could look at the time and decipher that if it's happening at night, then those clients must be werewolf clients. So that's pretty simple, and that actually won't work with the current state of the server, but it is a type of attack that we're looking for. And so in this bottom set of screenshots here, what we're looking at here is 2 different ways of writing to your pipe. In this top one, we're forking a system call and just running what you would do from the command line. Echo this string to this pipe. And the script down here at the bottom is showing how that kind of naive echoing to a pipe is actually very traceable in the system. And you can see how just a simple grep will pick that up. And this is in contrast to the second way of writing to the pipe down here. Just opening it as a file, it then is a Python script that's not, forking itself and creating a system call. So the same idea can be done with context switch counters. A context switch is when a process will, in this case, will voluntarily yield and let another process take over. And so in this case, the /proc file system has a list of all running processes, and you can look at voluntary context switch counters here. And if you systematically analyze all of the processes running, you'll see whose shells are yielding, and in effect, you can start to see who is communicating with the server and at what points in the game. So you can do these same kinds of side channel attacks with TCP keep alive timers and looking at the access time of shells, of PTYs. So I wanted to talk a little bit about some of the bugs that were found in our server. One of the more basic ones was the log permissions of the moderator. And by that I mean when a game is started, the moderator will output all of the data to a log file for analysis after the fact. And initially, this was happening in two steps: first an open, and then a change permissions. And so a smart player discovered that if they opened that file prior to the change permission, they're actually able to read the log file throughout the whole game. And so that was pretty crafty. There was another set of bugs where you could actually inject different commands into the server and do things like pose as other players, spoof your identity and claim you're a player that you actually aren't, and that created for some interesting social engineering attacks. You have the ability to pretend you're anyone else playing. What do you say at that point to get the whole class against you? Definitely caused some funny situations. There is some logical errors. If you created a client and didn't behave with the protocol that was kind of assigned, you could actually vote multiple times, skew the voting. Over time, it became disadvantageous for werewolves to communicate at all during their discussion phase, and that's because any kind of discussion would create noise, detectable noise in the system, and so they ended up just not communicating. And the way around that, we did things like require that werewolves vote unanimously to choose someone to eliminate, and we wouldn't tell werewolves who voted for whom, so that would force some kind of collaboration. We had a team do some numerical analysis of the votes. That was actually an unexpected one. So one of our teams discovered that there was a subset of 3 players that would never vote against each other, and that led them to deduce that they must be the werewolves if they're all teaming up against everybody else. We had a team brute force the root password. Well, attempt to. It actually wasn't successful. And we also had some command injection going on, kind of SQL injection-esque, where they were able to run commands as the moderator who had root on this virtual machine, and modify the server code itself. So the paper that we submitted here is talking a lot about how do we handle players that are able to dominate the game. And I talked a little bit about it throughout this presentation, but where we kind of landed was that being able to shuffle the players manually, take people who are really strong offensively at detecting the werewolves, forcing them to become a werewolf so that they were therefore made to become more defensive instead. that was kind of how we went about that. But it definitely is a topic that we've spent time talking about and kind of a hard problem. And the reason for that is, if you have balanced teams, the game's going to be a lot more fun and educational for everybody. So we also spent some time talking about evaluation here today, and that was something I wasn't. I wish that we had more kind of analysis of our data here, but we're working with a team in the library to kind of address that a little bit more at University of New Mexico, and it is an area for further development. Other things like more feature development, adding more special characters. There's there's fun gimmicks like extra voting, or this pair of characters called the Lovers, who are in effect a third team. Their only goal is to keep themselves alive. And then another bigger project that would be pretty interesting would be to change the base unit of communication into essentially an HTTP packet. And that would greatly change the dynamics of which kinds of attacks are possible and how you would go about playing the game, both offensively and defensively. So that is what I have. I'm happy to chat about anything I mentioned here. We have an email that you can check out if you want to talk to us about setting the game up. We have the code on Bitbucket here. We have a home page and some papers. So thanks, guys.
So actually a question. How long does it take before the players tend to discover the issues that, is there like a ramp up time that's slow? Is it pretty quick to see people start to find the side channels?
Well, so like I said, the style that we presented this game was we would have a lecture and talk about types of attacks at a high level, and then allow the teams of players to kind of sit down and code on it for a little bit. And so that obviously there's a lot of room for some teams were very quick to hop on leveraging the new techniques, whereas other teams were slower. But absolutely every week we were patching the server with something that new students found. And I'm sure there's still other bugs that exist that haven't been found yet. But it really depended on the exploit itself. Depending on the complexity, these exploits were found faster or slower. So
great.
Yeah.
Thank you.
Thanks, guys.
Oh,
One more.
You're going to get more applause than anyone else today.
Quick question: Do you force people to become werewolves in the middle of the game, or do you decide to do that before you start playing? Do you sort of scope out the students and say, okay, this team, that team, and
so kind of the steps of the game. You have your players connect, or you get the people around a table, and then you assign roles. And then your role is static throughout the game until you're either eliminated or you win. And games are pretty quick. So in a given hour, we were playing 4 or 5 times. So if you were eliminated, then you would just sit around for a few minutes until the next game started. But yeah, at the beginning of the game.
Could you tell how effective the learning outcomes were? Like, did it achieve your goals for having people learn the material?
So this was part of like I said, it was part of a cybersecurity class, and I mean just one lab of a class, and we had the students write up a list of the exploits that they discovered and used, and how they went about doing that in kind of a lab report at the end. And so that requiring the students to do that, it was kind of cool because it forced them to reflect on the attacks they did. Not just hack something into place, call it a day, and move on. And so that was really the metric that we have to watch students learn from this. Just kind of an after-the-fact reflection of what they did and how it worked, and also what they could have done differently. Frequently, we saw students, an exploit would come out, it would be game dominating, we'd shuffle the teams around so that player was, not ruining the game, and then the next week, all the players would have added that technique into their set of attacks. And so, that was proof that our students were picking up on what was possible and how to exploit it, but maybe just a little bit too late.